Hello everyone. Yeah, myself Priyabrata Nandi. I would like to start a new YouTube channel that is called Concept Raja. So what my channel is for, the aspirants who is who is going for any competitive exam like NEET, JEE or the school exams. So for this channel, what I am going to handle is that I will give you conceptual idea about the topics you are learning at your school level. So I would like to start the students who are in class 8, 9, 10, 11, 12. Okay, and who are looking for really looking for making their career on mathematics or physics. Okay, I'll cover the idea. I'll cover the topics based on mathematics and physics. And why I given the channel name as Concept Raja. Okay, see, my channel main agenda is that whatever the topics you're gonna learn, you have to have a very conceptually rich about that topic. That means you should know how the whatever the things we're learning, how we are going to apply that in your daily life. So I am giving a brief introduction for myself. I am working for almost it's my 18 years of experience I am having working for a financial industry, and I'm extensively work for a quantitative finance where I use lots of mathematical models. Okay, and so there what I realized that people who know they have done degrees. Even I have also whoever have completed the degrees, and when we come to the work there we see huge difference between our theoretical knowledge and the practical implementation of that chapters. So what I want, like whatever you are learning from the school levels, like the middle school or high school, you should know like what is the purpose of that learning and how do I go to apply that. So until your concept is very clear, you cannot apply that. Okay, so today I don't want to make waste much more time. Okay, I just wanted to start one of the topic, and I would like to say everyone, okay, it's not that I want to promote my channels and all that things. It is like I'll keep updating or keep uploading the videos one by one. Okay, as I make the videos, as I'm working, I am involved in my full-time work, okay, with some MNC companies. I might not get much time to do that, but whenever I'll get time I'll do that. But I will request everyone to share those videos who needs it. Okay, may not be like whoever needs it, please ask them to see the videos. If you like, comment it, okay, and give me the suggestions, because I am from a corporate background, I'm not from any academic background, but due to my interest, okay, and due to my experience, through the experience I have learned that I have to be, you have to very very conceptually rich about the topic you are doing. Otherwise it is very difficult for you to apply on the daily day-to-day life. Okay, let's start the things. So today I'm going to cover one of the physics topics. Okay, so I'll pick like physics or mathematics, any of the topics I'm going to pick it. And today I'm going to pick one of the physics topic that is called one of the very specific topics is like a gravitational potential. Okay, so why I pick this topic, I don't know, like I just randomly pick this topic. Okay, I know gravity is a huge topic in class 11 course, but there people, if you want to learn from the school levels, we have a tons of formulas, correct? We have a tons of formulas like what is gravity and what is acceleration due to gravity, gravitational force between two masses, all that things. We have tons of formulas. I'm not going to touch all that formulas, but what I'm going to do that I want to pick a simple topic and I want to apply like some mathematical concept on that. Okay, and I will show that how that mathematics is needed, and based on your feedback, based on your comment, what I'm gonna do that I will gradually start the mathematics, basic mathematics basic mathematics concept first, which is mainly needed for the physics. Okay, so that things, then I'm gonna slowly start the videos of the gradually one by one, okay, with all that thing. But today randomly I'm picking one topic. So today my topic is that gravitational potential. Okay, this may be very familiar for the students who know about the gravity, or may not be very familiar. may not be you have learned this gravitational potential in your school or in your teachers. I think, see, your teachers are very experienced on the academic side. I'm not that much experienced on the academic side. So whatever I'm going to say in this video, it is about the practical implication, or what is gravitational potential, why we need that, why we need this particular term. So that I'm going to discuss here. So before starting that, I'd like to say something about we need some mathematical background, correct? Like to do any physics, like when we learn the physics, even on the 11th standard, if I want to learn the physics, I need to have some mathematical background to learn the physics. So I just quickly give the the topics with the mathematics you need to learn. You need to have a clear idea. One is, I think, class 8 standard we have learned, like 7, 8 standard we have learned ratio and proportion, correct? So this is the very basic topic we have learned on the class 8, but this is very, very important, and most of the physics chapter we're going to apply all that thing. Now second thing is the vector algebra. This is the backbone of the physics, correct? This is the backbone of the physics. And I'm not telling like you have to be very pro about the vector algebra, but you should know about the vector algebra. What is vector algebra, what is vector, how we'll do the vector operations. So these things I'm not going to cover today, but I'm planning like I'm going to eventually cover one of the videos in the vector algebra, or I might need multiple videos to do that. Number 3, what I'm going to do that is what I'm asking for the two applications for the physics is that we need to know about the different graphs, like what the different graphs look like. Okay, what is the graphs of a straight line, what is the graphs of a parabola, what is the graphs of a ellipse, okay, how it looks like, what is the graphs of 1 by r, what is the graphs of 1 by r square, or 1 by x, 1 by x square, what is these graphs. So this we need to know about this. So all these things we can cover in different videos. Number 4, okay, in physics very important is that calculus, correct? So calculus, I think from the initial chapters only, if you see the class 11 chapters, everywhere you have to apply the calculus. But I know like if I see the syllabus, you have the calculus on the class 12 mainly. Okay, we start from the 11, like we have the limits and all that thing, but we start the calculus on the class 12. But I want you to know calculus from the basic of the calculus formulas and basic of the calculus, and obviously what calculus does, like conceptually you should know the calculus. And if I would like to start, I'll record that videos also soon about the calculus, like the topics we need for the physics application. Okay, and we need some of the probability concept as well, like we have the probability concept, like we have this permutation, combinations and all that thing. Okay, so we need that some basic ideas about that. So these are the main things I can come up, like if you want to learn physics, you should have a pretty good ideas, like at least have a good ideas to have apply all these topics, all this concept. And the last one but not the least is the very important, is the trigonometry. So without trigonometry we cannot move in physics. Okay, so these are the things like I'm going to cover like in future videos, but today let's concentrate on the gravitational potential. So now I'm going to explain like what is gravitational potential, and I will just show you gradually, like our main goal is to find the gravitational potential for our earth. Okay, that will be our main goal. So we have to fix our topic, like fix our goal, like why we're learning this. So we want to get the gravitational potential of my earth, like where we are living, earth. Because why? Because gravitational force, I know it is mainly applicable for the heavenly bodies, correct? So we have the different heavenly bodies, for that gravitational force is mainly applied for. So, and I'm not talking about the gravitational force now, I'm not talking about anything, but what I'm going to talk is that our main goal is to find the gravitational potential for the earth. So what is earth? Now come to mathematics. What is the earth? The earth is nothing but a sphere. We can say that earth is a sphere. So now my main objective is to find the gravitational force or gravitational potential, okay, rather gravitational, not force, gravitational potential of the earth in the different positions. Okay, suppose if some some, what is the sum after the some distance, like from the earth center, like what is the potential here. Okay, and why we learn potential, what is there in potential, why not learn directly? Because we have if you have in the physics, if you learn the physics, you have already had some chapters covered, like work energy, there you have learned the potential energy, correct? We call that a term called potential energy. Instead of potential energy, why we learn the potential? Okay, so guys, I want to make these videos in two languages, mainly on the two languages. Okay, my primary will be English, and I would like to speak sometimes in Bengali. Okay, because I want all the Bengali students, okay, should understand like why I'm what I'm teaching here. It's not like that they will not understand English, but I'll just speak Bengali because Bengali is my mother tongue. So I would like to do on that also. Okay, now okay, let's start with the gravitational potential. Okay, I not because I've given a brief introduction about my intention of this channel. Now what is gravitational potential? Okay, now in our space, like if I consider the space, we have lots of heavenly bodies in the space, correct? We have a big mass on the space, or system of masses in the space, and like so when there is a heavenly bodies, okay, they have their own gravitational force. Okay, and this gravitational force, when there is a, suppose this is a space and I have taken one heavenly bodies, okay, and here if I put some small test mass, okay, what is test mass? Test mass is a mass which is very small, which cannot create a field around him. Okay, this is the any hypothetical situation where I am keeping a test mass. So what is this test mass feeling the force? Okay, what is this test mass feeling the gravitational force? So this, what is this, the test mass feeling the gravitational force due to this heavenly bodies is called the gravitational field. Now I came up with a one term called gravitational field. And when I move this test mass, okay, so now the important concept is that test mass, whatever this is a hypothetical mass, okay, and this test mass, okay, is very thin, very tiny, okay, and the mass of this test mass is small m, and this mass of this heavenly bodies is capital M. Now, so what this gravitational, it's feeling a field, okay, gravitational force, which is called a gravitational field. And if I move this mass, like now what I'm getting, so how the force will apply on this test mass in this direction, correct? We know that it will apply on the straight line between the center of that bodies and the test mass, correct? So this is the things, and this is a very small mass, so I can consider it as a point mass. Okay, now what is happening here? We have seen that this is the gravitational field I'm telling. Okay, so this gravitational force it is experiencing due to this big mass, correct? Now, so this, mathematically I can, this gravitational field, I have two quantities, correct? Two physical quantities. Okay, what are the two physical quantities? I can divide this gravitational field as one is like a vector quantity. Now I'm coming to the mathematics. One is vector quantity, one is scalar quantity. Where we are getting the vector quantity and how we are getting the scalar quantity, let's come see what is vector quantity. So now I assume that you know all these concepts, all these mathematical concepts. Okay, I know what what is vector, what is scalar. Okay, as today is the introduction video and today is the demo video, so I would like to say like this vector quantity, scalar quantity, these things I'm gonna explain you in a separate videos, but now I know, I assume you know this. So what is vector quantity? Vector quantity is nothing but the the vector is the system where it is having a magnitude and direction. So these are maybe very technical term or technical jargons, but these are very easy things. I think as a student you should know all these terms. ভেক্টর মানে যার একটা নিজস্ব ম্যাগনিটিউড আছে আর যার একটা নিজস্ব ডাইরেকশন আছে। ডাইরেকশন মানে কোনো একটা দিকে, পার্টিকুলার দিকে এটা কাজ করবে। সো ইট উইল হ্যাভ সাম পার্টিকুলার ডাইরেকশন, ওকে। and in our 11-12 chapter we have a maximum 3 dimension, correct, like x, y and z axis. Okay, but mostly we'll talk about the vectors on the xy axis, but we have a z axis as well. And when we cover the vector algebra, their details I'll cover up, like what is vector and how vector works. Okay, now so what is a vector quantity? Amra jani as per the force, like force is a vector, correct, like force is a vector, work done is a scalar, correct. I am just assuming that you know all these concepts, like force is a vector and scalar, work done is a scalar, or energy is a scalar, correct. You know all, like I am assuming you know these things. Now when there is a gravitational field it is experiencing due to this big mass, what is happening? So it is having a force vector. So it is this test mass is feeling a force, correct. That force I can say is the gravitational field strength or intensity. So this is intensity and the field strength. And now this test mass getting a force to that, and if you want to move this test mass from one position to another position, then this test mass has to do that gravitational force is do some work on the test mass, correct. And that work done, that moving the test mass, okay, is one point to another point is the gravitational potential. So what is the definition wise how we can say that? So now let's see this this test mass. I told that test mass is m. Okay, now for that m mass I am feeling some gravitational force. What is this gravitational force I'll face? M mass will face the gmm by r square. Which direction? This direction. So I know this direction is always negative, this direction is positive. So whenever the relative to this mass, if direction is on this side, towards its side it will be negative. So this is the force it is feeling, okay. And I am giving it as a gmm by r square. R is the distance between this COM and the test mass. And now what is gravitational field intensity, which I can represent as a E, is nothing but the per unit mass. So for m mass this is the force, then unit mass this is the divided by m. So this is the gravitational field, okay. So gravitational field is nothing but the force experienced by a unit test mass placed on a gravitational force extracted by the big mass or a heavenly bodies. What is gravitational potential? Okay, so we know this is a scalar quantity. Gravitational potential will be scalar quantity. So this would be either work done, okay, or the work done by the the gravitational force, that gravitational force or field. And this is related to the work done by the gravitational force, okay, moving this unit mass, okay, from one position to another position. Okay, so gravitational potential, what does it mean? If I write in generally we represent it as a V, and if I have a point, suppose in a point P I am keeping this gravitational the test mass m. So gravitational potential is nothing but the, and we know like potential energy, when we learn about the potential energy, correct, you have already learned that potential energy definition. If you see in the physics, this is a change in potential energy is nothing but the negative work done by the conservative force. Okay, now what is conservative force? All that things we can cover, or you may, I think you have lots of videos for that. You can see all those things like what is conservative force, what is non-conservative force. So now based on the definition, what is that? Okay, the potential is nothing but the negative work done. What is negative work? Negative work done, okay, by the conservative force from bringing a mass from infinity to some point, like my reference point is P, okay, and if I for the unit mass. Okay, now why we need the gravitational potential? There is a term called potential energy, correct? Why? What is the need of potential? Okay, why we can use the potential energy, correct? Now when we calculate the potential energy, so there I have a particular mass for that, like I will calculate the potential energy for a particular given mass. Now this is like a, when I am calculating gravitational potential, I am calculating the potential energy for a unit mass. Okay, so I can compare it like a, if I have a, see, one chocolate price is 10 rupees, then what is the chocolate price? 10 chocolate price, correct? I can calculate the 10 chocolate price is 100 rupees, correct? Now here I am calculating the unit price of a some items. Gravitational potential is nothing but the unit energy, like the gravitational potential is nothing but defined as the negative work done by the gravitational force. Okay, it is by the unit test mass. So if I have a unit test mass, like I have a gravitational potential of a some point, like I have a some point P, if I calculate the gravitational potential, now I can bring any mass, like I have a, for one chocolate I have already 10 rupees, correct? Now I buy any chocolates, I can immediately calculate the price of that, correct? So if I get the gravitational potential of a point, then I can easily calculate the potential energy will acquire by some mass if I keep that mass on that point. That is the main thing. So I believe you understand. Again I will repeat, is nothing, gravitational potential is nothing but that it is a reference from to a point. Okay, and if you want to bring some mass to that point, then that mass will acquire what much potential energy on that point, correct? So that's why this is very important concept on the gravitational potential, or when we'll have a electrostatic or magnetic, like everywhere potential means you can understand, correct? The work done by the conservative force on the unit test mass on that particular point, correct? And why we need this? This is a reference, correct? We need some reference, correct? When we calculate something, we need some reference from there, like I told, correct? Like if I have a unit price or unit thing, correct, like I have calculated the reference for that. From that reference I can calculate any mass potentials. Like why you need the potential? Because I can immediately calculate the potential energy acquired by any mass on that particular point. Okay, now let's start with the, now this is the let's start with the I think the main thing is that let's start with the potential, calculate the potential for different different bodies, like gravitational potential. It is defined for a unit mass is nothing but the, how we define for a unit mass, we'll calculate we'll calculate that. How we calculate that, how that, suppose I kept a unit like kept a point mass here m, okay, which is having a gravitational field, okay, gravitational field I'm not covering in this video, gravitational field intensity which will work towards the center, okay, due to this field, okay, field means nothing but the force, correct? The intensity of the field is nothing but the force, and it is a vector quantity, so it will have a direction, and I from that particular point P, what the gravitational potential will be there, okay, what will be the gravitational potential on this particular point P. Now I will gonna calculate that. See, I hope you have a clear idea about what is potential now. Potential, again I am telling you, is nothing but the reference of a, at a point where one big mass will have create that potential. That means what, if I bring any mass on that point, okay, so that mass will acquire some potential energy due to this gravitational potential. So that is the gravitational potential. Why you need potential? Potential will give a reference like a unit mass, correct? Potential is for a potential energy per unit mass. Now whatever mass I will get, if I get a gravitational potential formula derived, then I can immediately multiply the mass and I will get the gravitational potential energy. okay, for that particular mass, what is the potential energy that mass acquire. Like potential energy, correct? Like we generally say, like in earth, if I move some mass from h h height, like I move m mass h height, what is the potential energy that mass will gain is nothing but the mgh. This is a very one of the initial concept of the potential energy, we know that, correct? Mgh, correct? So this potential energy for the m mass. Okay, then what is this gravitational potential on that? It is like nothing but the g into h, correct? And all this thing, like let's derive the potential for a given mass.